Alright, so today we are looking at 1.4 spatial concepts. So our tidbit of the day is the rock at the top of Mount Everest is marine limestone and would have been deposited on the sea floor around 450 million years ago. Okay, so 1.4, our objective for this lesson is to define major geographic concepts that illustrate spatial relationships. We're going to be introduced to a new tool for this section, and this is called thinking like a geographer. And basically when we're thinking like a geographer, we're asking 4 questions and looking for something else. So we want to know what, where, why there, and why care, or so what. And the thing that we look for is patterns. So we're gonna, if we're looking at maps, if we're looking at graphs, data, documents, whatever we're looking at, we're going to use this tool to kind of help us to think like a geographer. So thinking about what is place? How do we describe what a location is like? So a place is a specific spot on Earth, and to have a sense of place, we have factors that contribute to the uniqueness of a location. So think about what gives Port Orchard a sense of place. What makes you know that you're in Port Orchard versus in Seattle or in Tacoma or in Bremerton? We have a cultural landscape. This is the built environment. So it's what we see around us that we as humans have implemented. So the physical artifacts that humans create that make up the landscape. This is human produced and contrasts the physical landscape or the natural landscape. And then we have placelessness. So placelessness is a location without a sense of place, no distinct attributes. Where is location. So it's a little bit different than place. So what is place? We're looking at what's defining that. Location is where that place is. So we look at absolute versus relative location. We look at things like toponyms. A toponym is a place name. Topo meaning place, nym meaning name. This is the location's name, and it's usually reflective of the culture or the history of that place. So places like Georgetown, Washington, Santa Barbara, any of these things are telling us something about the culture of that place. And then we look at the site and the physical location. So we have site and we have situation, and we're going to talk about that. But site is the physical landscape. These are the environmental features of a location, and it includes things like climate, water sources, topography, soil, vegetation, and elevation. And when we look at this map, we are looking at climate zones. So you can see everything on here. We have a little legend on the side. We can see differences throughout the entire planet, but we see commonalities along latitudes, and that's really important to note. Patterns are spatial analysis. We're looking to analyze space when we look at patterns. And I see now that my slideshow's a little bit messed up, but I'll just tell you what it says. What patterns can be determined? And we're looking for particular things in here. So the first one is clustering, which we talked about 2 videos ago. Clustering means that things are close together, and density refers to the number of something in a defined area. So remember, I could have 9 dots in one box, and that density is going to be the same no matter where those 9 dots are. But if they're all smushed in this corner, they're clustered. But if they're all spread out, they're dispersed. And that means that they're farther apart. So dispersal or distribution refers to the whatevers being far apart. So distribution is the way that something is spread out over an area. Basically what we're looking for here are patterns and spatial associations. So this is an indication that 2 or more phenomena may be related, associated, or correlated with one another. Patterns are relationships. That's what we're really looking for, and spatial associations are relationships. Dang, I messed this all up. All right. So what patterns can be determined? And this says regionalisation. So number 4, regionalisation. This is the process that geographers use to divide and categorize a space into smaller areas of analysis. So we can look at the entire world, but that's a little bit difficult to do all in one because the world is really big. So it makes it much more reasonable to try to look at a smaller space. And we think of that smaller space as a region. Now, we could pick Africa. Africa, remember, is a continent, not a country, but it's also huge. And Northern Africa is not at all like Central or Southern Africa. And that becomes important when we're trying to look at different things. So we can start to regionalize things. So we might have North Africa, and this is a little bit different of a regionalization than we might otherwise see, because here we see several different regions in Africa: North Africa, West, Central, Southern, and East Africa. We could also look at Sub-Saharan Africa and North Africa, but each of these places is going to be rather different. Some of it is a desert, some of it is a tropical jungle, some of it's Sahara, and those are all totally different, and that means that development happens differently there. And kind of the same when we look at really anywhere in the world, but if we look at Asia, Asia is incredibly diverse geographically and by population, so it doesn't make a lot of sense to try to look at it all as one big whole. We have to divide and categorize that space so that we can better analyze it. So the why there and why care. This is essentially, we want to know what are the implications when we get to that why care. Why does it matter? First off, why there? What's happening? So we look at spatial interactions, and these are connections, contacts, movement, and flow of things between places. So we look at a few different concepts, geographic concepts, to explain connectedness or lack of connectedness of places, locations, and phenomenons. And one of the ones that I already have mentioned to you is time-space compression, but we also look at distance decay. So distance decay basically says that the farther two things are apart, the less likely they are to interact. So as distance increases, the interaction decays. And this is the interaction between two places declines as the distance between the two places increases. Exactly what I just said. So physical barriers, mountains, rivers, oceans, deserts are all things that are going to increase space between two things. And cultural barriers, language, religion. So the farther away we get from Mexico, the less likely we are to speak Spanish. That's distance decay. Or the farther we get away from the American South, the less likely we are to hear a Southern accent. So that's part of that language. So looking at the maps on this side of the screen, ignore everything on the right-hand side for a minute. So this is the idea of the shrinking globe, and it doesn't mean that the globe is literally shrinking. The physical space is exactly the same, the land area is the same, but the perceived size of the globe is smaller. So from 1500 to 1850, the best average speed of a horse-drawn carriage or a sailing ship was about 10 miles per hour. It takes a very long time to get anywhere. But by 1850 to 1930, we have now increased our speed through steam locomotives and steamships. So trains can go about 65 miles per hour, so about 6.5 times as fast, and steamships can go about 38 miles per hour, so about 4 times as fast. And that's going to make the world seem much, much smaller. But again, remember, it seems smaller, it's not physically smaller. By the 1950s, we have propellered aircraft, and these are going to go from about 300 to 400 miles per hour. This is going to make the world seem even smaller. Things are closer together. Not everybody is using these technologies just yet, but it makes the world seem way smaller. And then by the 1960s, we've implemented jet passenger aircraft, which travel about 600 to 700 miles per hour. And lots and lots of people use them. We use them to transport people and goods, and it makes the world seem incredibly small. So in a pretty short amount of time, only about 100 or so years, we go from a huge globe to a very small one. And then we have diffusion, and diffusion basically is just the spread of a characteristic. So it might be an idea, it might be a material good, whatever it is. And we have two types. We have expansion diffusion and we have relocation diffusion. So expansion means that that characteristic is growing in amount. It is spreading wide. And then we have relocation diffusion, which isn't necessarily that it's increasing, it's that that characteristic is picking up in one place and moving to another place. So it's not increasing, it's just changing where it is. So what, where, why there, so what, and patterns. So what, where, patterns, why there, why care, or so what. Our what here, on the left-hand side of the screen, we are looking at the population density of China. And that's part of the what. We can also include a bit in there that we see an urban population, we see population density. We could talk a bit about the rivers and the water, whatever. So where? We're looking at China and we're looking at where this population is located. Patterns, well, I see that the highest concentration of population density, the most people per square kilometer, are in the coastal areas or in the overall eastern half of China. They seem to be fairly clustered, so the populations are clustered. Why there? If I look at this map, I want to know why are the people where they are? And what I can see is that there's a lot of water over here, because this is coastal, and I see rivers going through here, and what I don't see are rivers over here. So you're looking for things that you do see and things that you don't see. And that tells me that it's really hard to live over here. We need water to drink, to cook with, to bathe with, but also to transport goods and people. Over here makes a lot more sense, especially when I see the very big cities are right on the coast, because those are the places producing things and sending people and goods across the water. What are the implications? Okay, why do we care? What happens if there's an earthquake? What happens if there is a huge spread of disease like there is right now? What are the implications of that? What does it also mean that there's so much population here, but so little population here? Why does that even matter? And I want you to kind of think about those same ideas as you're looking at this map over here. Here we're looking at who's breathing in the most air pollution, so particulate matter. And what is that doing to their health? In the same idea, here we're looking at two maps of China, the before and after of air pollution with the coronavirus quarantine. So when do we have more pollution? When do we have less? What are the implications? All right, that's it. So our lesson objective for 1.4 was to define major geographic concepts that illustrate spatial relationships. Go into your books, make sure you're reading and taking notes from there. When you are all finished, make sure you take the mini quiz to go along with this lesson. And that's it for today. So let me know if you have any questions. Go back and re-watch if you missed anything, or if you want to hear it again to make it a little bit more clear. And have a great day. Bye.